Welcome now, Science Mr. Robertson, back in action with some new words you got to learn today. Okay, the first one is on the board. The first one says mass. Now this word, you may know things that are massive. If something is massive, it is huge. Just like my biceps. They are huge, they are massive. Because if something has more mass, it is gonna be bigger. That's how mass works. Mass is basically the science word for how much stuff there is. How many atoms they are and how big those atoms are. And it could be how much mass the air is, how much mass my teeth are, how much mass my hair is. Probably too much of all of this gel in my hair. That's what mass is. It's the amount of stuff that is going on. We measure that stuff using kilograms, kg. And that is what is used around the world. Remember, 1 kilogram is kilo. It equals 1,000 grams. And we use that everywhere in the world. I say everywhere. There's a couple of places in the world where this is not common. In one country which has a flag like this, with some stars over here or whatever, the USA. It is very common for people when they talk about their weight and how much they are. Now, I am about 76 kilos, hopefully, maybe, I don't know. But I would say in America that instead I would be something pounds. Pounds, which annoyingly has the symbol LB. What you can do is remember that 1 kilogram equals 2.2 pounds. About. It's not perfect. But certainly in America, that is what we have. In this bit of science, there's quite a lot of numbers. There's quite a lot of math. I'm never going to assess you on your math skills, but by understanding this, you can understand how we use the science, and that will help with the later topics, I promise. In America, we would say pounds. In another country with a silly flag, that's a bit like this. The background's good. The blue is gorgeous, the blue and the white. Oh, flood of Scotland, when will we see your light again? Then we have that stupid, horrible red stuff that comes over it. You know, destroying my flag with this red here. Of course, the United Kingdom. In the United Kingdom, when we talk somebody's weight, we would say they are something stone. I am, I think, just under 12 stone. I don't know. I've been in Sweden so long, I've forgotten. But that's what we used to measure. With older people in the USA and the UK, you might have some trouble in finding, oh, you're 50 kilograms, what is that? My dad doesn't understand. He knows 50 grams is, but he can't think, 50 is like, how big is that? They much come with pounds and with stone. It's getting better. In the UK, I think people my age understand and can use it okay. But certainly, this is what is more common. But around the world, we use kilograms. In science, we use kilograms. Everybody uses the same system, and that's what we want. That mass. To calculate mass, we use something like this. These here, we have 2 of them with batteries loaded in the lab. These are our scales, eller våg. And these claim to tell me how much something is, how much mass it has. I can go here and I can see it can measure up to 5,000 grams to the nearest 1 gram. So it can tell me if something is 477 or 478 but it can't do any more exact than that. That is the maximum it can do for how precise it is. I need to take this off. So with those scales, it says it's telling me what I have as kilograms. But it's not strictly true. It's strictly doing something else. It's strictly telling me the force. Because it's telling me how hard that mass is pushing down on me. And remember, mass pushes down, at least on Earth, because we have an acceleration. Because this mass here will accelerate. 3, 2, 1. It goes down. It's been pulled down because of Earth's gravitational attraction. At least here, that is our acceleration. And if I'm in Sweden, and if I'm in the UK and America, it does not matter. That is about the same. It is about 10 meters per second squared. That is how I measure acceleration. And pretty much everywhere on the Earth, that is true. If you're up a big mountain, you're slightly further away from the middle of Earth, and it's slightly smaller. But I mean slightly. Not really enough for me to notice. The mass is how much stuff. My pen is here, my pen is in America, my pen is in the UK, my pen is in Kazakhstan. I don't know where it is, but it is the same pen. No different. What I am actually measuring is the force, how big that push is. But of course, I can pretend it's mass because the acceleration is the same, so I don't notice. Maybe it's 478 here, and on a mountain in Scotland it's 477, but we're talking tiny differences. What we use to measure force is something named after a famous scientist who saw an apple fall from a tree and hit him on the head. It's a lie. That story is fake. Fake news. But that apple story inspires what we all know about Mr. Isaac Newton. Isaac Newton gives the name to what we call a force. Force is measured in newtons. And this is easy maths. If my mass is 5 kilograms and my acceleration is 10 meters per second squared, then I have 5 times 10, 50 newtons. That is easy. That you can all do. Technically, I'm measuring force. But human beings are lazy. We say mass because I'm not going to the moon. So I don't need to know what the newtons is. I need to know the mass. I need to know how much stuff there is. And it works. It's fine. However, I can expand upon all of this here with mass. And I can work out not just how heavy something is, but how tightly packed it is. Because remember, different things have different shapes. I could have this here with a shape. The volume of this here, which is our next keyword, is going to be like this here. Measuring these 3 sides could be 3, 4, and 5. Let's say it's centimeters. And I would do 3 times 4 times 5. 3 times 4 is 12, times by 5 is 60, and then centimeter, centimeter, centimeter is centimeters cubed. That there is the volume for this. Volume is a great thing that I can measure, because then I can see how tightly packed it is. Because different materials are differently packed. These balls are pretty much the same volume, but this one weighs so much more than this one. My iron ball is much heavier than my cotton ball. This comes to the word that links to volume called density. And that ball is rolling away, it's so annoying. Quick tip. Density of a ball is really hard because you can't measure it really easy. We have a made glass, and hopefully I can do this, hold it really steady. I should be on a table. But watch the water level. So I'll bring it closer. The water level has slightly gone up as I drop the ball in. And then if you see how much it goes up, you can work out the volume. That's smart thinking. Density. Finally, get this really done. We're in 11 minutes. Let's finish this. Density is how packed the material is with mass. So if I have the mass and I divide it by the volume, I get the density. Density has no funny scientist, no funny Newton or anything. The mass is in kilograms, and the volume, it could be centimeters cubed, it could be meters cubed, it could be whatever. Then density is kilograms divided by centimeters cubed. It does not change. We use whatever units we have, but that also makes it really easy to remember that it's density. It's how much mass is in how much space. The cotton has a very low mass and a very low density. My metal ball has a high mass and a very high density. 3 key words: mass, volume, density. Words we're going to be using a lot in class. Good luck with the questions.